The National Electrical Code does not explicitly require all lighting circuits to be 15 amps. The common misconception often stems from typical residential wiring practices. Many residential lighting circuits are installed utilizing 14-gauge wire. According to the NEC and relevant electrical standards, 14-gauge copper wire, when used in typical building wiring applications, has a maximum ampacity of 15 amps. Ampacity refers to the current carrying capacity of a conductor, which is the maximum amount of electrical current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. This temperature rating is crucial because excessive heat can damage the wire's insulation, potentially leading to short circuits, fires, and other electrical hazards. The NEC establishes ampacity ratings for various wire gauges and insulation types to ensure electrical safety and prevent overheating. Since 14-gauge wire is commonly used for residential lighting circuits, these circuits are typically protected by a 15-amp circuit breaker. The circuit breaker is a safety device designed to protect the wiring from overcurrents. If the current in the circuit exceeds 15 amps, the circuit breaker will trip, interrupting the flow of electricity and preventing damage to the wiring. However, it is important to understand that the NEC does not prohibit the use of larger gauge wire, such as 12-gauge wire, for lighting circuits. 12-gauge copper wire has a higher ampacity, typically 20 amps, and can be used with a 20-amp circuit breaker. Using a larger gauge wire provides a greater margin of safety and can accommodate higher lighting loads. The choice of wire gauge and circuit breaker size depends on the anticipated load of the lighting circuit. The load is the total amount of electrical power, measured in watts, that the lighting fixtures connected to the circuit will draw. To determine the appropriate wire gauge and circuit breaker size, it is necessary to calculate the total load of the lighting circuit. This calculation involves adding up the wattage of all the lighting fixtures that will be connected to the circuit. The NEC provides guidelines for calculating the load of lighting circuits, taking into account factors such as the type of lighting fixtures, the area being illuminated, and the occupancy of the building. Once the total load is determined, the appropriate wire gauge and circuit breaker size can be selected based on the NEC ampacity tables and overcurrent protection requirements. It is crucial to comply with the NEC requirements to ensure electrical safety and prevent electrical hazards. Always consult with a qualified electrician to determine the appropriate wiring and overcurrent protection for your lighting circuits. In summary, while many residential lighting circuits are wired with 14-gauge wire and protected by 15-amp circuit breakers, this is due to the ampacity of the wire and not a strict NEC requirement mandating all lighting circuits be 15 amps. The NEC allows for the use of larger gauge wire and higher amperage circuit breakers for lighting circuits, provided that the wiring and overcurrent protection are properly sized to accommodate the load. Therefore, one should carefully assess the specific requirements of the lighting installation and consult with a qualified electrician to ensure compliance with the NEC and ensure electrical safety. The NEC provides comprehensive guidelines for electrical installations, including wiring methods, overcurrent protection, grounding, and bonding. It is essential to understand and comply with these requirements to ensure the safety of people and property. Here are some key points to remember. Firstly, the NEC does not mandate that all lighting circuits be 15 amps. Secondly, most residential lighting circuits use 14-gauge wire, which has a maximum ampacity of 15 amps. Thirdly, circuit breakers are designed to protect wiring from overcurrents. Fourthly, larger gauge wire, such as 12-gauge wire, can be used for lighting circuits if needed. Fifthly, the choice of wire gauge and circuit breaker size depends on the anticipated load of the lighting circuit. Sixthly, always consult with a qualified electrician for electrical installations. Understanding these key points will help to clarify the NEC requirements for lighting circuits and ensure electrical safety. Further considerations involve understanding voltage drop. Voltage drop refers to the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause lighting fixtures to dim, appliances to malfunction, and motors to overheat. The NEC specifies maximum voltage drop limits for branch circuits and feeders to ensure proper equipment operation and prevent safety hazards. To minimize voltage drop, it is essential to use conductors of adequate size and minimize the length of the circuit. The NEC provides formulas and tables for calculating voltage drop, taking into account factors such as the conductor's resistance, the length of the circuit, and the current flowing through the conductor. Another important aspect of lighting circuit design is grounding and bonding. Grounding refers to the connection of electrical equipment and wiring to the earth, providing a low impedance path for fault currents to flow back to the source. Bonding refers to the connection of metallic parts of electrical equipment and wiring together, creating an electrically conductive path that ensures all parts are at the same potential. Grounding and bonding are essential for electrical safety, as they help to prevent electrical shock hazards and facilitate the operation of overcurrent protection devices. The NEC specifies detailed requirements for grounding and bonding, including the size and type of grounding conductors, the methods of connecting grounding electrodes, and the bonding of metallic enclosures and equipment. In addition to the NEC, local electrical codes and regulations may also apply to lighting circuit installation. These local codes may have additional requirements or restrictions that must be followed. It is essential to check with the local electrical authority to determine the applicable codes and regulations for your area. Proper planning and design are crucial for ensuring the safety and reliability of lighting circuits. Before beginning any electrical work, it is essential to create a detailed plan that outlines the wiring layout, the location of lighting fixtures, the size and type of conductors, and the overcurrent protection devices to be used. The plan should be reviewed by a qualified electrician to ensure compliance with the NEC and local codes. When installing lighting circuits, it is important to follow all safety precautions and use appropriate personal protective equipment. Always energize the circuit before working on any electrical wiring. Use insulated tools and wear safety glasses to protect yourself from electrical shock and other hazards. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. The selection of lighting fixtures can also impact the design and installation of lighting circuits. Different types of lighting fixtures have different wattage ratings and require different wiring methods. It is important to choose lighting fixtures that are appropriate for the intended use and that comply with the NEC requirements. For example, recessed lighting fixtures must be installed in accordance with the NEC requirements for thermal protection and clearance from combustible materials. Furthermore, energy efficiency is an increasingly important consideration in lighting circuit design. Energy-efficient lighting fixtures, such as LED lighting, can significantly reduce energy consumption and lower electricity bills. The NEC encourages the use of energy-efficient lighting fixtures and provides guidelines for designing energy-efficient lighting systems. In conclusion, designing and installing lighting circuits requires a thorough understanding of the NEC, local codes, and electrical safety principles. While the NEC does not mandate that all lighting circuits be 15 amps, it is essential to select the appropriate wire gauge and overcurrent protection based on the anticipated load and to comply with all applicable codes and regulations. Consulting with a qualified electrician is always recommended to ensure the safety and reliability of lighting circuit installations. Remember that electrical work can be dangerous, and it is always best to err on the side of caution. If you are not comfortable working with electricity, leave it to the professionals. A qualified electrician has the knowledge, skills, and experience to safely and properly install lighting circuits in accordance with the NEC and local codes. This will ensure that your lighting system is safe, reliable, and energy efficient. Also, remember to consider the future needs of your lighting system when designing and installing lighting circuits. It is often a good idea to install extra circuits or larger gauge wire to accommodate future expansion or changes in lighting requirements. This can save you time and money in the long run. Finally, be sure to properly label all lighting circuits in your electrical panel. This will make it easier to identify and troubleshoot circuits in the future. Use a permanent marker to label each circuit breaker with a brief description of the circuits that it controls. This will help prevent confusion and ensure that the correct circuit is energized when performing maintenance or repairs. By following these guidelines, you can ensure that your lighting circuits are safe, reliable, and code compliant. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns.